What are the laws of thermodynamics? Contrary to common sense, the first law of thermodynamics is not actually the first law of thermodynamics. It is actually the 0th law of thermodynamics. This law states that if two materials don't transfer heat between them, then if one of those materials won't transfer heat to a third material, then that first one will also not transfer heat to that third material. This might seem very obvious, at least if you think about what happens when you mix two liquids of the same temperature together. But this law gives us our scientific definition for temperature, seeing as, generally, instead of saying these objects are in thermal equilibrium, we would just say that they have the same temperature. Now then, moving on to the first law of thermodynamics. This law states that energy cannot be created or destroyed. We all know, of course, that you can turn energy from one form into another by doing something like burning an oil to turn its chemical energy into thermal energy. Now, some might get confused when you realize that nuclear energy and nuclear reactions create energy seemingly from nowhere. This is because the mass of the nuclear fuel is used to generate the energy. This can also be seen during supernova, where when a large amount of energy is released, some of it is also absorbed back into atoms in order to generate more mass. So the actual scientific definition of this law isn't that the total energy of an isolated system is constant. It is instead that the total mass energy of an isolated system is constant. Next up, we're moving on to the second law of thermodynamics. This law states that entropy always increases. Entropy is a term used in all forms of science, including computer sciences. For this law, we're going to be defining entropy as a measure of how spread out the energy and molecules are in the universe. This law tells us that the entropy of the universe will always increase. This means that over time, your car will break down and it will not spontaneously repair itself. As if it were to spontaneously repair itself, that would leave it in a state of lower entropy than it was at initially. The other major implication of this law is the heat death of the universe. The heat death of the universe is a hypothesized scenario where the energy and molecules of the universe are uniformly spread out throughout space. If this is true, the universe will become an unchanging sea of plasma. Now I'm moving on to the third law. This law states that the entropy of a material approaches a constant value as the temperature of that material approaches 0 Kelvin. If you think back to the previous definition of entropy I gave you, that definition of entropy is incomplete. For the purposes of this law, the definition of entropy we'll be using is it is a measure of the number of different ways the energy in a system can be arranged while making the system look the same from the outside. This makes a lot more sense when you consider that temperature is a measure of the average energy of molecules of a material. And so as temperature decreases, the total amount of energy in the system also decreases, and therefore the number of ways that energy can be distributed throughout that system is also lower. If you're just beginning to learn about thermodynamics, you might wonder what the point of this law is. Well, this law tells us that entropy decreases with temperature. We can then go on to use this aspect of the law to produce a different definition for entropy. All in all, this tells us that entropy is very, very hard to define. If you've looked at some of my other videos, you might know that there exist far more definitions of entropy than the ones presented in this video. Many of these alternative definitions describe the same phenomenon, but using certain language that makes it easier to use in certain fields, such as computer science or statistical thermodynamics, as opposed to classical thermodynamics. If you want to see more science content like this, please like and subscribe and check out the rest of my channel.